Okay, I'm just going to show you how to do custom error bars on Google Sheets. I discovered this on a YouTube clip a few days ago, and it showed how biology students could do this, but this can show you how physics students can do this. And to show you what I'm going to end up with, it's a graph like this, where we have to label, of course, the y value, the x variable, and you're going to have a legend here with all the points, but the main thing is that you've got the maximum and minimum lines of best fit and their formulas. Notice that we have these points here, and each error bar has got a different size. And this is what I'm going to show you to do. So this is what we're going to end up with, and I'm going to show you how to do this. Let's delete these. Delete all these. Yep. Okay, so we have to go back to our basic data. We've got variable x, and I made up some values like 1, 2, 3, 4, 5. Okay, these are the 5 x values that I'm choosing, and then I try x value. Okay, let's get rid of all these. Yeah. Okay, so we start with the different values for the x variable, and we do 3 trials for the y variable, and let's say the values are 3, oh that seems awfully small, but okay, 11 and 19, quite a large variation there. The second point was the x value was 2, 18, 21 and 24 and so on. What we have to do is find the average here, so let's do the average of those 3. And this is the average is 11. I'm going to drag down, these are all the average values that we have. So we're going to plot a graph of x against the average y. Now we need to find the size of the error bars. So we write equals the minimum value of those 3. Okay, that didn't quite work. Minimum, open brackets, those 3. Close brackets, fine. So these are the minimum values. That the minimum value was 3. The maximum value is equals maximum, open brackets, of those 3. Obviously it's going to be 19. So let's close that bracket now. Yep. So I'm going to repeat all of these and drag it down. So we now have all the minimum and maximum values. What is the range? Well, the range is obviously equal to the maximum minus the minimum there. So that's 16. Let's drag those down, and we're going to find half the range. That's going to be equal to the 16 divided by 2, so that's 8, and we're going to drag down here. So this is how far we would go, and really we can't get much further than this. Now the way we actually do custom error bars is to say that each one of these average is a set of data in itself. So let's copy down these values, control copy V. Now this first value 11, we're going to take that as a first data set, control copy, and that's basically going to be the first point. Now I need to do paste the values only, of course. This is control copy, that's the second point, paste the values, excuse me, that should be 21. Well, okay, you get it. We have to do, this is going to be 31, that's going to be 41, that's going to be 51. Those are the different values. So each point is a data set in itself. And because each data set can have its own size error bar, that's how we're going to do this. Now all these values need to go in here, of course. Control copy, control paste. Of course we need to do the values only, fine. Okay, so these correspond to the average values. We also need to work out what is going to be the maximum line of best fit. Now the maximum line of best fit from the smallest value, which is x is equal to 1, it's going to be 11 minus half the range. So it's going to be, what is 11 equals 11 minus 8? That's going to be 3. And this is going to, the minimum line is going to be 11 plus 8, which of course is equal to 11 plus 8. Fine, so we've got 19 there. The maximum line of best fit is going to go to the highest value, which is 51, is going to be plus this uncertainty here. So it's going to be equal to 51, this one, plus the uncertainty, which is 4. And this is going to be equal to 51 minus the uncertainty. Okay, so this is going to be our maximum line of best fit. This is going to be our minimum line of best fit. So what I'm going to do now is to plot a graph with the x against y. I'm also going to put the maximum and minimum lines of best fit there as well. So let's see what this looks like. So let's take all this data, insert graph, a chart they call it. Okay, let's get this there. It's not a column chart, it's going to be a scatter graph. Let's move down to scatter graph. There we go. So there we have it. Now it should look familiar here. Now, as I said, the minimum line of best fit is one set of data values. It's called a data series. The maximum line of best fit is another set of data series. Okay, what I want to do is, first of all, let's take this one here, and okay, this is the average, we call it average y. Let's take the graph actually, and I want to look at all these different series. Oops, we don't want it to do that. No, okay, that's not behaving. Let's try it here instead. Series. Okay, let's look at the average. We'll just leave it for average y at the moment. What I want to do is, there are no error bars with this. What I want to do is to put the equation now, the trend line, and we're going to show the label there, use equation. Yeah, there we go. That's the equation for the average. Let's do the same for the y values, sorry, the maximum line of best fit. That's series, this one here. This time we want to do the formula for this one as well. So let's go down, trend line, let's put the values, which is, use the equation, and that's the equation for the maximum line of best fit. Let's do the same for the minimum line of best fit. So let's go down and let's do the trend line for this one as well, and we have to give it a name, and it's going to be the equation. So now already we've got these formulas here showing the maximum line of best fit, the minimum line of best fit, and the average. This is all stuff you know already. Now the most useful thing is actually to do individual error bars here. Now let's take the first point. So let's take this series, it's 0.1. Okay, now we're going to be looking at error bars. If you notice the first point here, it's got a half range of 8. So this has an error, which is an absolute, a constant error of 8. So we put 8 there. Fine. We don't want the trend line, we just want 8. So that is error bars being drawn that you can't actually see it because it's underneath the maximum and minimum lines of best fit. So let's go to the second point, which is point 2, which is basically another data series, but only with one point. We're going to do the same thing here. Here the error is 3, the uncertainty is 3. So we're going to do error bars, and this is not a percentage, this is constant, and this is going to be 3. Okay, now we go to the third point. So the third data point is 3. Here we have the uncertainty is 7. So here we put the uncertainty, where is it? Error bars. Percent, no, it's going to be constant is 7. Fine. Now we look at the fourth point. 0.4. So we scroll down. Here again, we want error bars. 4 has got an uncertainty of 4. So that goes to 4, and that's going to be a constant uncertainty. And the last point is series 5. And let's scroll down. This has an uncertainty of 4 as well. So error bars, 4, and it's going to be constant. Fine. Now you can see quite nicely that we have individual error bars, basically because each of these points is also a unique set, and you've decided what the size of that uncertainty is for each set. It's only 1 point for each one. So there we have it. Now, of course, we have to try to get it so that all the maximum and minimum lines of best fit go through all error bars, which they do except this one. So we need to basically pull this one down and pull this one up so that both of these lines go through here. Let's start with the let's start with the maximum line of best fit. At the moment it starts at 3. I think it needs to start at a bit higher than that. Let's start with 5 instead. And that's better, but maybe a bit higher is better still. 6. Fine. 6 is good for that. We need to get this 20, it's actually 19, to bring that down. And let's bring it down by 3 to 16, 15, let's say. That's too much. Let's go to 16. Fine, and there you go. So there we have these maximum and minimum lines of best fit, all of which go through the error bars. Fine, so let's take this. You can of course change the title of this. You need to give a y axis description. You need to give an x axis description. But let's have a closer look at all these values. So look at that. Look how nice that is. You've got the maximum error bars were here, but we had to reduce these value and increase the value so that we have the maximum minimum lines of best fit go through all the data points and all the error bars, which they do now. Now, a couple of things is that if this is too big, you can always change the size of this. We go to series again, and you could always do this. This is 0.3, I think. One nice thing would be with the error bars, but to look at the point size. Let's make it 0.2 instead. So that's a bit smaller, and let's make the maximum, the average value. Let's give that, the average value. Let's make the point actually smaller, because sometimes these dots can be a bit big. So let's reduce the size of that dot so it's 2 pixels. So there you have it. This one's 2 pixels now. So you can do the rest you can do that the same with all these others. So you get this nice small point with a very clear error bar. If you don't like the colored error bars, what you can do is change all the colors to black. Of course, this is the average value, but we leave that in another color. But let's say we take this let's take the 4th point, which is series 4. Let's change the color of that one from green to black, and of course it goes to a black error bar, which is much nicer. So there you have it. So you can actually produce custom error bars on your physics graph to show the maximum minimum lines of best fit. So you can do all. This is a bit of a workaround, as you say, because you have to produce all these separate series. But in the end, it's the thing that you want to produce. So you don't need to use other software. One downside is that what you do notice is that you've got this legend. So what I'm going to do is see if I can change that. I can't delete the legend because then I'll get rid of all these graphs, but I can put it underneath maybe. The legend, let's put it to the bottom. That might be a bit better. That way we've got more space to see what we want on the graph. Oh, excuse me. There we go. Now look at that. Lovely.